Hello everyone, welcome to Civil Engineering and Stuff. And in today's video lecture, we are going to discuss about the consumptive use of a crop. Now, the consumptive use of a crop is defined as the total amount of water consumed by plant during its evapotranspiration process. So let us understand what does this evapotranspiration process means. This evapotranspiration is a combination of two process, that is the evaporation and transpiration. Now, what is evaporation and what is transpiration? So, in a soil, let's say this is your soil, and in this soil grown certain, you have grown certain crop, you have grown certain crop, and of course, irrigation is done to fulfill the nutrition need of these crop. Now, whatever water, whatever water is lost as a vapor by the neighboring soil, whatever moisture loss is taking place by the neighboring soil in the form of vapor is what we define as the evaporation. So evaporation is the water from soil adjacent to plant that passes into the atmosphere in the form of vapor. Okay, you can see if these are our plants. So whatever water that is lost is in the form of vapor through the adjacent soil is what we call as the evaporation. Transpiration is that the water entering plant roots and used for building plant tissues, this water passes into atmosphere in the form of vapor from plant leaves. This means that there is a loss of water from the adjacent soil of the plant, which we call as the evaporation. And at the same time, the roots of the plants absorbs the moisture from the soil and fulfill their nutrition need. The excess quantity of water that the roots absorb is lost by the plant or discarded by the plants in the form of vapor that excretes through the leaves of the plants. Right? So again, certain water vapor are left from the leaves of the plant, and this is what we call as the transpiration. Right? The amount of water that is lost in the form of vapor from the leaves of the plant is the transpiration, and evaporation is the water lost in the form of vapor from the adjacent soil of the plants is what we call as the evaporation. So combination of these transpiration process and evaporation is what we call as the evapotranspiration. Combination of transpiration and evaporation process is what we call as the evapotranspiration. Correct. So your total quantity of water consumed by plant during its evapotranspiration process. All right. So the total quantity of water that has been supplied the plant during the plant growth, and out of this, whatever water is being lost from the neighboring soil as well as from the leaves of the plant. All right, this is your evaporation, this is your transpiration. Combination of these two is what we call as the evapotranspiration. This is your evapotranspiration, and the net quantity of water that is consumed or that is consumed to fulfill this evapotranspiration need is what we call as the consumptive use of the crop. The net quantity of water that fulfills this evapotranspiration need is what we call as the consumptive use of the plant or a crop, as the case may be. All right. So there are some technical terms with respect to the consumptive use, in which the first one is the potential evapotranspiration. The first term is potential evapotranspiration. Now, what is this potential evapotranspiration? So, of course, we have a plant, correct? We have a plant, and there is certain need of evapotranspiration of this plant. There is certain evapotranspiration need of the plant. Now, if we supply an unlimited quantity of water. What we do? We supply we supply an unlimited quantity of water to the soil, and the roots of the plant absorbs this moisture in the soil and fulfill its nutrition value, and then discard the excess quantity of water through through transpiration process, right? So once we are supplying an unlimited quantity of water, and from this unlimited quantity of water, the transpiration need is being fulfilled and evaporation need of the soil is also being fulfilled, right? So so the net evapotranspiration value that we get when we supply the unlimited quantity of water for a certain crop is what we call as the potential evapotranspiration, or known as the PET. It is the amount of evapotranspiration that will occur if an unlimited amount of water is available or supplied to a specific crop. All right, and like it's a hypothetical rate of use of moisture, right? Like when, as and when there is certain moisture requirement for a particular crop that is supplied, right? So it's a ideal situation, a hypothetical situation, right? And here it is assumed that the crop completely covers the ground surface under irrigation and evapotranspiration take place through plant. All right, like total idealistic condition is assumed, and here it is like taken into consideration that there is not much of the soil is available throughout the land surface. Throughout the land surface, the we have sown the crop, right? So and from there, whatever the conceptual use that we get is what we call as the potential evapotranspiration. Next we have is the actual evapotranspiration. Now this PET value is your ideal value, and AET will be, as the name suggests, it is the actual value. So actual quantity of water is being supplied to a plant on a realistic basis, and during this scenario, whatever loss of moisture that takes place through evaporation and transpiration, that is what we call as the actual evapotranspiration. Actual amount of evapotranspiration that occurs in the limited time and in limited supply of water is called as the actual evapotranspiration, right? And it is a function of both meteorological factors and the factor related to plant and soil, like the actual scenario. Okay, so part of the water will be supplied through rain, and part of the water may be supplied through irrigation. The frequency of supply of water may not be constant. So the practical on a practical level, whatever is the evapotranspiration need of a crop is what we call as the actual evapotranspiration. Like when actually on field the water is being supplied, and during that whatever is the ET value is called as the actual evapotranspiration. Okay, so we have PET and AET. PET the ideal situation, AET is the actual situation. So if AET divided by PET is less than 1, this means, what does this mean? If actual evapotranspiration is potential evapotranspiration less than 1, this means whatever was the requirement of the crop, whatever was the conceptual use requirement of the crop, we are not supplying that much quantity of water. So of course the soil will start to dry. And for clay soil, AET by PET value is equals to 1. Now, if actual evapotranspiration value on a field we observe to be 0, right? This means, what does this mean is that practically we are not supplying any water, neither through natural source, neither through irrigation. All right, we are not supplying any moisture to the soil, and because of that, the crop is not able to fulfill its evapotranspiration need. And when this is happening, so eventually what will happen? The moisture level of the soil will keep on going down and will eventually reaching its wilting point. All right. So if AT value is 0, this means the soil moisture has reached to its wilting point. All right. We have discussed what wilting point is. And likewise, we have discussed the different moisture content, that is field capacity level, optimum moisture content level, and the wilting points in the previous lectures. You can refer to those lectures for more information on these. Now, if ET value is equals to ET value, this means whatever was the moisture requirement of a crop to fulfill its evapotranspiration need, we are supplying that. So this means the moisture level is up to its field capacity. All right. When whatever PET is what? Like PET value is when you are supplying the required quantity of water, or whatever is the evapotranspiration need of water, you are supplying that much quantity of water, and infinite value of water you are supplying, and plant is fulfilling its ET value. All right. So when this is happening, then and in case this AT value becomes equals to PET, this means we practically on field we are achieving the idealistic situation. All right. So this means during this scenario, the soil moisture of the soil, the moisture of the soil will be equal to its field capacity. All right. Again, we have discussed about these terms in the previous lectures. You can refer to those for a better understanding of these terms. All right. Now, there are certain other technical terms that are related to consumptive use. The first one is the effective rainfall. And effective rainfall is defined as the precipitation falling down the growing period of a crop that is available to meet the evapotranspiration need of the crop. Let's understand what does this effective rainfall means. So, like we have discussed that we have a land or a soil, and over that grown we have grown certain crop. We have grown certain crop, and of course these crop have certain evapotranspiration need. Correct. Now they how these evapotranspiration need will be fulfilled by supplying water. Now, as and when this water is being supplied through natural rainfall, okay, when there is a natural rainfall occurring, and whatever is the consumptive use of the crop, or whatever is the evapotranspiration need of the crop, the this rainfall is fulfilling this evapotranspiration need either partially or fully. All right. So that the rainfall or the rainwater that fulfills the evapotranspiration need of the crop is what we are referring to as the effective rainfall. Effective rainfall is the precipitation falling down the growing period of a crop that is available to meet the evapotranspiration need of the crop. Okay, through the natural rainfall, we are or the crop is fulfilling the evapotranspiration need. So as and when that quantity of rainfall that is fulfilling the evapotranspiration need is what we call as the effective rainfall. All right, because we know that as and when rainfall happens, as and when a rainfall happens, part of the water is is lost to surface runoff. Part of the water may percolate and meet the natural groundwater source. This water is not available for the crop to be used for any fulfilling its nutrition value or to fulfill its evapotranspiration need, right? But then there will be after some time there will once the soil achieves its once the surface runoff takes place and soil achieves its saturation value, then through this whatever water that we have got through the rainfall, the crop may fulfill its ET value. All right, and that rainfall water is called as the effective rainfall. Okay, I hope this term effective rainfall is clear. Okay, it is absolutely that quantity of water that of the rainfall that fulfills the evapotranspiration. That's it. Next we have is the consumptive irrigation requirement of the crop. Now, what is the consumptive irrigation requirement of the crop? Let's say this is your crop, right? And the rainfall is taking place, correct? The rainfall is taking place, and we have right now discussed that the part of the water of the rainfall may be lost to the surface runoff. Part of the water may percolate and meet the natural groundwater. All right, and whatever moisture that is available from the rainfall, through this moisture, the 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 crop fulfill its evapotranspiration need. Correct. Now, this through this rainfall, let's say there was 10 centimeter of water was required. Just for example, I'm saying the 10 centimeter of water was required to fulfill the ET need of the crop. But through the rainfall or through the effective rainfall, only 5 centimeter of water could be provided to fulfill the ET need. Right? Only 5 centimeters of the effective rainfall we could get. So again, but the crop need 10 centimeters. So still 5 centimeter of depth of water is remaining to be supplied to fulfill the ET need of the crop. So how will we supply this 5 centimeter? We'll supply this 5 centimeter through the irrigation. That is the artificial application of water. Correct. So this consumptive irrigation requirement, this consumptive irrigation requirement is this extra quantity of water that you are supplying through irrigation to fulfill the consumptive use of the crop or the evapotranspiration need of the crop. All right, it is the amount of irrigation required to meet the evapotranspiration need of the crop. Correct. So part of the evapotranspiration need of the crop was fulfilled through effective rainfall, but still our plant or the crop required some more quantity of water to fulfill its evapotranspiration need. So the overall quantity was CU. Consumptive use of the crop is the quantity of water that is required to fulfill the evapotranspiration need. Part of this was fulfilled through effective rainfall, and the remaining part remaining part we have to supply through irrigation, and that is what we call as the consumptive irrigation requirement. All right, so consumptive irrigation requirement is this extra quantity of water that we need to supply to fulfill the evapotranspiration need of the crop. If there was effective rainfall is equal to 0, this means all the rainfall was converted into surface runoff. None of the water was available for the plants or the crop to fulfill their evapotranspiration need. Then RE value will be 0. It may happen when the soil is clayey and there is inclined plane, right? And so as and when the rainfall happens, all of the water is converted into surface runoff, and the plants do not there's no water available for the plants to fulfill their evapotranspiration need. Correct. So this is what you call as the consumptive irrigation requirement, Cu minus Re. All right. Then we have the net irrigation requirement, and the net irrigation requirement is defined as the extra quantity of water that is required to fulfill the other needs of the crop. Other needs of the crop basically comes as the leaching requirement of the crop. Okay. So out of all the consumptive use, part of the water was used for the like after the effective rainfall has taken place, part of the irrigation is required to fulfill the consumptive use of the crop, and then an extra quantity of water supplied to fulfill other requirement of the crop like leaching activity is required. So this net quantity of irrigation is what we call as the net irrigation requirement. The overall quantity of water required for irrigation is what we call as the net irrigation requirement. It is Cu minus Re plus the water lost in percolation satisfying other needs like leaching, etc. All right. Then we have the consumptive use efficiency, and it is the ratio of water used consumptively to net amount of water depleted from the root zone. Like it is similar to the water application efficiency, and we have discussed about the water application efficiency in the previous lectures. So you can refer to that for more detail. All right, water consumptive use efficiency and water application efficiency are more or less are like similar terms, but this water application efficiency, when discussed in terms of consumptive use, it is the same. That is the ratio of water used consumptively to net amount of water depleted from the root zone. Okay. Then we have the field irrigation requirement, and it is the ratio of the net irrigation requirement divided by the consumptive use efficiency. Net irrigation requirement we have already discussed. Then we have the gross irrigation requirement, and gross irrigation requirement is the ratio of the field irrigation requirement divided by the water conveyance efficiency. Again, we have discussed about the water conveyance efficiency in the previous lectures. All right. So you can refer to these irrigation efficiencies and other type of irrigation efficiency for more details. Okay. Now, next we have the factors affecting the consumptive use of the crop. So there are a number of factors which affect the consumptive use of the crop, in which the first one is the humidity and climatic conditions. Now, if the humidity is more, then evaporation will definitely be less, and because of which the evapotranspiration, like overall water required for evapotranspiration, will also be less. Then we have the mean monthly temperature, and again, if temperature is more, then the evaporation will be more. The transpiration required will be somewhat towards the higher side, and since the evaporation is more, the evapotranspiration will be higher. And since ET value is higher, this means the consumptive use, like we need more to supply more water to fulfill this consumptive use of the crop. So the overall CU value will increase, and in this case it will decrease. Then we have the crop period. We have discussed what is base period and crop period in the previous lectures. So uh, crop if the crop period is higher, then of course the quantity of water required will be higher, and because of which the consumptive use of the crop will be higher. Next we have the rainfall during the crop period, and if we discuss in terms of the effective rainfall, if the effective rainfall increases, then of course the consumptive use will decrease, because uh, because CIR value is CU minus RE. If we have if RE value becomes equal to CU value, that is all the consumptive use requirement was fulfilled through effective rainfall, then we don't need much of the water, right? So to a greater extent it will decrease. If we supply enough quantity of water, then of course the consumptive use of the crop will decrease. Then we have soil and topography, irregular topography. If we have irregular topography, then what will happen is that the rainfall water or any water that is supplied to fulfill its consumptive use will move forward and basically be collected at this site, right? So in an irregular topography and uh, irregular plains, what will happen is the consumptive use requirement becomes somewhat higher. We need to supply more water to fulfill the evapotranspiration need of the crop. Likewise, if our soil is somewhat porous in nature, if our soil is somewhat porous in nature, then whatever water that we supply, instead of getting absorbed by the roots of the crop, it will percolate into this from the soil and will meet the groundwater table, right? So the roots of the crop will not be able to utilize this amount of water for to fulfill their nutrition value and evapotranspiration need, right? So if the soil is porous, then we need more water to fulfill the evapotranspiration need of the crop. Likewise, if we have the irregular topography, then CU value will increase. All right. Then we have the irrigation techniques, and again it depends upon the type of irrigation. It depends upon the type of irrigation. All right. So if we are using flood irrigation, then the quantity of C value will increase, because the distribution of water is not even in flood irrigation. While in the more sophisticated form of irrigation, we are moving to the better irrigation technique, the better supply of water will be there, and because of which the CU value will decrease. Then we have wind velocity, and like higher the wind velocity, more will be the evaporation. If higher is the wind velocity, more will be the evaporation, and because of which the consumptive requirement of the crop will increase. All right. Next, we have the methods to determine the consumptive use of the crop. Now, broadly speaking, there are two categories by which the consumptive use of the crop is determined. The first one is the direct method, and the second one is the indirect method. In the direct method, we have the various methods like tank lesimeter methods, field experimental plots, inflow outflow studies, and soil moisture methods. So basically, your direct methods are field based method or the experimental based method, and from these the practical data or the actual field based data are collected, and from there the conservative use of a certain crop or a plant is found. Now, based upon the long data that we get from the direct method, certain empirical equations are formed, and through these empirical equations, again, the conservative use of the crop is found. So these indirect methods are Blaney-Criddle method, Penman's equation method, Hargreaves class A method. Okay, so these are your indirect method and these are your direct method. And in the subsequent lecture, we are going to discuss about these types of methods in detail. All right. So for today, for this video, this is all for the video. I hope the lecture was useful to you. If so, like the video, comment your views in the comment section. Subscribe to the channel for more videos like this. Thank you for watching. Have a nice day.